Hello there. Today we have a very fun problem. It's called the Tower of Hanoi. So the Tower of Hanoi is a mathematical puzzle. It consists of 3 poles and a number of discs of different sizes which can slide onto any pole. The puzzle starts with the disc in a neat stack in ascending order, and we need to move all of these discs from the source pole, the first pole, to the third pole. So let me give you an example. So suppose we have one item, right? And now we need to move this from the first pole to the third pole. So this will take us a total of like 1 move, right? Suppose we have 2 items, right? And now we have to move these items to our second pole. How would we move these items? Well, we would move the first item to our first pole, our other pole, then move the second item to our third pole. Then lastly, we're going to move the item 1 to our third pole, which would total about 3 moves, right? And lastly, oh, my mistake. And lastly, we have a total of 3 items, and so we need to move all 3 items onto the third stack. So how do we do that? Well, we can just move these 2 items, which we can do recursively. So we basically, if we're able to move it here, then we're able to move it to the other spot, right? So suppose that we do all the operations that were required of us to move it to the end. We do it and move it to the other spot. So that means we move the 1 all the way to the end. Well, not all the way to the end. That means we moved 1 here, move the 2 over here, move the 1 back, move the 2 back, move the 1 over. Now they're on this the second stack, and now we can move the 3 over to the end stack, right? The third stack, which we wanted to do in the first place. And now we can move all the items from the other stack back onto our third stack. And that's how we complete this problem. Now, if we can do it for 3 items, then we can do it for 4 items. Because, so what I mean is, recursively speaking, we can move all 3 items onto our other stack, right? And now we can move this 4th item onto our third stack, and now we can move all of these 3 items back onto the 4th stack. Now we have 1, 2, 3, 4. I don't know exactly how many moves it would take, but the solution here that we need is to find number of moves that it will take. Currently, we'll be doing this in this video recursively. In the next video, we will be seeing how we can do this iteratively. So, one video that is extremely illustrative about how this is done is linked here. I will also link it in my video, so I will show you that later. So let's just, I think with that, we understand the problem. Let's also work out the edge cases. What if someone puts out a 0? If 0 and below, let's just ignore those. Ignore ignore it. Ignore any number 0 below. Okay, and what if, we have a input that's way too large for our call stack? I think our call stack was 900 or something, somewhere around there, and we don't have that much memory, and so I don't think we're gonna have. Let's just call it at 10. Let's just call it at 10. 10 items. All right, max. So with those parameters, I think we're ready to begin. So let's check out the plan. The plan is that we will be using recursion, and that means we need to make a base case. So that's the match. Sorry, my bad. Match for the umpire method. Excuse me. So plan. The plan is we will make a base case. Base case is at 1. That's moving from 1 to 3, or 1 to 2. It doesn't matter. Wherever it goes, it's going to cost 1. The second case is that it's 2 or more, right? And we need to move n minus 1 to the other spot before we can move n to the n minus 1 to n spot, because we need to move largest item, right? So we will move the n minus 1 to the other spot and move the n minus 1 to the large spot, the n spot. Okay, and we'll be doing this for every call for our call stack. Now, anything else that we need to note is that we want to print the movement and get total moves. Okay, and we will be doing that. Let's implement. So let's define solve Hanoi. And we need an n, the number of items that we would take in our starting spot and our end spot. Okay, so, and we will be returning an int for a number of moves. So for our review, what we'll be looking at is all of the examples that I showed earlier. So we're going to print out the solve Hanoi at, we need to do return statements. So first, so fn equals 1, return 1. Okay, so solve Hanoi 1. Start from 1, and we're going to end at 3. And we're going to print 2 items, starting from 2, ending at 3. And we're going to print 3 items, and starting from 1, ending at 3. And we're going to print 4 items, just for the heck of it, and so on and so forth. Okay, so we have this part here. And we also need to print the moves. So that means we need to print move from start and end. And we just need to do a print statement. Print, format, we're going to do start, going to the end spots. Okay, so we need a print move here. We'll do a start and our end. Okay, and otherwise, what we need to do in our plan is that we need to move n minus 1 to the other spot. To get the other spot, that's going to be equal to 6 minus the start plus the n. The reason why is because we have 3 total spots. We have 1 plus 2 plus 3. That's how we're going to call these things, right? And therefore, there could be only the other spot must be, if we do the subtraction, it could be 1, it could be 2, it could be 3. We're going to go to any of these 3 spots. Okay. Now, with that, let's move all n minus 1 from n minus 1 from start to other. Okay, and this means that we can print the move that was taken. We can also get the total moves. And we can also get the total moves plus equals 1, and total moves plus equals solve Hanoi from n minus 1 to start from utter to end. So we moved all the items to the utter and -1 items to utter. We made that one move to get the largest item, and lastly, we're gonna move the whole stack back onto the endpoint that we want. And with that, let's return the total moves. Okay, and that's the problem. Once we have the review, so what is the O of n time? Well, the O of the n time seems to be, it's going to be like, so we had 3 items, and 3 is 15, and what about 4? What about 4 items? So how far will that take us? So I don't see a console log here. Maybe something weird's going on. Let's print that. Yeah, this is for 4 items. It's 15. So for 3 items, it's 7. So it looks like it's let's try 5. Let's see what is the pattern here. If we do 5, I'm guessing it's 24, 31. I'm not so sure what is exactly the. It looks like it doubles every single time, and you add 1 move. So I'm predicting for 6, it's going to be 63 moves. Okay, so let's see. Let me just pull up number 6 and let's see how many moves it is. So we have 63 moves. It was as predicted. So it's every time we do Hanoi, it's going to be 2 times the previous item plus 1. So that means this is 1. This is 2 times 1 plus 1. This is 3. 2 times 3, that's 7. This is 15. This is going to be 31. And this is going to be 63, right? So it looks like it doubles every single time. So it means that it's not O of n. It's O of to some sort of power. Is it what happens when you, I don't know exactly the expression, but it's double the previous amount. So I'm not sure. So but we can look it up. So Google, let's check out O of n double previous value. It's 2 to the x, so 2 to the n. Is it 2 to the 6 power? Yes, it is 2 to the 6 power. That's right. So it's 2 to the n power for evaluation. So about this, like, how 2 to the n power, and how are you going to solve this without Google during an interview? Well, I think you can just tell the interviewer that's exactly what it is. I'm not quite remembering exactly what was the timing for that, but I do remember now. It's 2 to the n, and one way to like think about it is, you see this is let's say 2, 4, 8. 2 to the 3rd is 8. 2 to the 4th is 16. 2 to the 5th is 32. And so on and so forth. So it's 2 to the n. If you can see that pattern, and then you just subtract 1 from that. That's one way to do it. Yeah, I mean, we could solve this problem in O of 2, O of, like, let's just say 1, actually, if we don't need to print out all the moves, and we just need to find the total number of moves, we can just say, oh, what are you looking for? You're looking for n? Okay, we'll just take 2 to n minus 1 from that. And we have O of 1 solution. We're not solving Towers of Hanoi, we're solving for the number of moves, right? But I'm pretty sure we're solving for Hanoi here. So, which means you have to print out all the moves. That was necessary. But if we're solving for number of moves, it's going to be 2 to the n minus 1. 2 to the n minus 1, that's going to be exact. 2 to the n is our total time. Space is going to take 2 to the n as well because of the recursion that we're doing. Of course, if we did this iteratively speaking, then it's going to be O of 1 if we did the iteratively speaking, because we forget about the previous move. For recursion, we have to remember the moves, and that's why it's going to be 2 to the n power of space. With that, we have solved the Tower of Hanoi in recursively, and we will be solving it iteratively next. Thank you very much for watching the video. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. And make sure you watch the video that I watched to learn about the Tower of Hanoi, and it made so much more sense. So I'll see you in the next one. Thank you.